Okay, let's give you guys some more practice. So here, somehow integrate this. So press pause and have a go. Okay, so to do this, let W be this thing here. So let W be x squared. So if W equals x squared, then dW equals this. Divide both sides by 2x, that will then give you this. So dx equals this thing here. So we can put this into the dx, and we can put the W here into here. Then this whole thing here will take us to here. So now these two will cancel out, leaving us with this. So now it's just a matter of integrating this. So now we're going to use integration by parts to integrate this. So integrate this using integration by parts. So imagine this thing as this thing multiplying with the number 1. So let v prime equals 1. Let u equals this thing here. So if u equals this thing here, then we now need to differentiate this. So we're going to take care of this later on. If v prime equals 1, then integrate it, then normal v will be w. So now we need to know this. So if u equals this thing here, then u prime, well, will be us trying to differentiate this. So now let's try and differentiate this. So in order for us to work this out, we would need to differentiate this basically. Well, if you differentiate this, so let's now try and differentiate this. So let's just say y equals this thing here. We are now trying to differentiate this. So let y equals this thing. We've done this many times in the past. So you should know this by now. So now sign equally to both sides. That will then take you to here. Now use implicit differentiation. So differentiate this would be cos of y, but because y is a function of x, we need to stick this in here. Differentiate this, it will then give you this, and then dy by dx equals this thing here. So now the thing is, when you use implicit differentiation, it normally gives you something in terms of y. So we would need to go back to here, and then use this statement here to translate this. So now going back to here, we will need to create a scenario in such a way that this statement is true. So let's draw a diagram. So we've done this many times in the past, so you should know how to do this by now. So looking at this statement here, try and create a diagram in such a way that this statement here is true. So let w equals this, then let this be. So looking at this here, we need to create a diagram in such a way that this statement is true. So let this be w, let this be 1. So if this is w and this is 1, then this length here must be this thing here. So this angle here is y. So sine of y equals this thing here. Then looking at the diagram, cos, because we are trying to translate this cos of y. So cos would be this thing here, which will be this thing divided by 1. So cos of y is actually this thing here divided by 1, which is that thing there. So that would be this. And then now looking at this, so dy by dx equals this thing here. So we can now put this into here. So dy by dx equals this thing here. Okay. So now going back to where we were before, we were trying to use integration by parts on this. We needed to differentiate this. Now we know how to differentiate this now. So when you differentiate this, it will then give you this. So now we can use integration by parts. So blindly follow this instruction here. It's saying get u times v. It's saying get u times v. So that will be w inverse sine of w, and then minus the integral. It's saying get u prime times v. It's saying get u prime times v. So that will be w over root blah 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 dw here. So this whole thing here will then take us to here. Okay. So now Now visualize this thing here as this. So visualize. So here you've got this thing here is really w times 1 over the square root of 1. But visualize the square root as to the power of a half. But then you can rewrite this thing here as this thing here. Okay. So anyway, visualize this thing here as this thing here, and here notice that when you try and notice that this thing here is almost a derivative of this thing here. So this thing here is actually quite easy to integrate. So integrating this whole thing here will then give us this. Because if you look at this here, you're trying to integrate this, but so here you've got one block multiplying with another block. This block here is almost the exact derivative of this thing here. So you know it should be easy to integrate. So integrating this would be, well, let's try and integrate this. So integrating this would be us trying to find something in such a way that it would differentiate to this whole thing. So let's make our initial guess to be 1 minus w squared to the power of 1 notch higher than this. So that would be a half here. So now if we try and differentiate this, it would give us well, this thing goes down, so that would be a half. The bubble stays intact, and then this thing here gets minus by 1, so that would be minus a half, and then times with the derivative of this bubble here. So times the derivative of that would be negative 2w here. Okay, tidy this up, then you have minus w 1 blah blah to the power of minus to the power of minus a half here. You see, this thing here is almost the same as this. We just need to negate this thing. So make the adjustment to our initial guess. Our initial guess is this. So now so blah blah. So you got a negative here and a negative here. So it will give you a positive. Okay. Well, integrate this. It will then give you this thing here. And then earlier we said let w equals x squared. So now we can replace all the w's here. So that will then give us this. So our final answer is this. Okay.